Alright, here we go. This lesson is going to be about completing the square. Now, you may remember from factoring that we have, factoring of a perfect trinomial where we would have x plus 7 and x plus 7 before we wrote it here, but before we factored it, if we were to FOIL this out, it would be x squared plus 14x plus 49, and that was our perfect trinomial. So from there, we would factor it, and we get x plus 7 and x plus 7, and then we would write it like this. Well, same with this guy. This is going to be x minus 5 and x minus 5. All you have to do is FOIL it together. We get x squared minus 10x plus 25. And what we're going to be doing is we are going to be turning some of these binomials into trinomials that are a perfect square trinomial. And to do that, it's called completing the square. So being able to complete the square is a very important skill because that's just one of your little prerequisites is finding C. We are going to be doing a lot more with this. So what I am about to show you is very, very important. Okay? So to complete the square, what you need to do is C is going to be equal to half of B squared. So this guy, of course, is our B. We have ax squared plus bx plus c. So what we're going to do is we're going to take half of 6, which is 3, square it, and we get 9. So c is equal to 9. That's what you're going to have to do. Okay, and then to write this as a perfect square trinomial, what you do is we're just going to call this x squared plus 6x plus 9. Alright, that's how we do A. So this next one, again, you're just going to have to take half of 2.4, which is 1.2, square it, and we're going to end up with 1.44. So then this one is x squared plus 2.4x plus 1.44. Alright, so I'm going to let C and D be all you. Go ahead and pause the video and find C and then write the expression as a square of a binomial. Okay, so you should have had 25/4 for C, and you should have 9 over 100 for D. Now that last part, writing as the square of a binomial, that looks like this. If we were to factor this, we'd have x plus 3 and x plus 3. This one would be x minus 5 halves and x minus 5 halves. This one over here would be x plus 1.2, x plus 1.2. And this would be x minus 3/10, x minus 3/10. So this is how we write them as the square of a binomial like we used to do when we factored a few days ago. Okay? So, like I said, being able to find C, that's just a little skill. Now we are about to go apply it to write equations in vertex form, and we're also going to solve. We're going to do quite a few things with completing the square. So I will step you through how to do one of these, and then we're going to obviously let you have the opportunity to try one. So we're going to start with this guy. The first thing you need to do is I like to just ignore y for a little bit, and you need to have x squared plus 4x on one side, and we leave a little bit of room and we set it equal to 1. You want to move this over to the other side, so to say. And the reason we leave this space is because you have to balance this equation. You can't just add something to it. And this is completing the square. So half of 4 is 2, squared is 4, so we have to add the 4 to both sides. Okay? Now, what we do is we're going to write this as the square of a binomial. So this is going to be x squared, or I'm sorry, x plus 2 squared equals 5. And then, to write this in vertex form, you bring the 5 back to the other side. So this is x plus 2 squared minus 5, and now we throw that y equals back in there. And that is how you change a quadratic from standard form into vertex form. And then of course we have to list the vertex, which is -2, -5. Okay, so that's how we do it step by step for a regular x squared. When we get to something like b and c, there's a lot of extra work involved. So why don't we step you through b step by step. Okay, so again, like I said, I kind of just pretend the y isn't there for the moment. Or if you really want to, you can leave the y there and subtract the 92 to the left, and then you leave the 1/3 x squared minus 12x over here, and then the 92 is still out of the way. So what we're going to do before this gets started is we need to factor out the leading coefficient. It's not the GCF. We need to factor out the leading coefficient no matter what it is. So we are dividing out a 1/3. That's why this actually does not become what you think it might become. It becomes minus 36x. Okay? And then we have plus, leave a little bit of space for the completing the square part of this. Okay? So remember, this negative 36 came from negative 12 divided by 1/3. When you factor something out, you're actually dividing. So we have our y minus 92 plus we have to leave a little bit of space for the completing the square part. So half of 36 is 18 squared, which is 324. So over here, what are we going to add? Well, you are not going to add 324. You are actually going to add 108. And the reason why is because this side you didn't really add 324. You added 324 times 1/3, which is 108 if we were to distribute this back in there. Okay? So now what we're going to have to do is combine our like terms on this side. So on this side we're actually going to have a 16. So we have y plus 16 is equal to 1/3 times, and then write it as the square of a binomial. So half of this is 18 squared. So we have y is equal to 1/3 times x minus 18 minus 16 once we bring him back over to the other side. And our vertex is 18 comma negative 16. So you go try C. Alright, so let's see if you got what I got, but I'm going to step you through the whole thing. I'm going to go back to my style, and I'm going to call this negative 2x squared plus 8x, and then we're going to leave a little space is equal to a negative 18. And then what we're going to do is factor out the negative 2, leaving us with x squared minus 4x on the inside. Leave that little bit of space again, is equal to negative 18. What goes in that little space? Half of 4 squared is still 4. And on this side, we're going to subtract 8 because we need to multiply it by a negative 2 first. So negative 2 times 4 is a negative 8. So we're going to come back over here. We have negative 2. Write this as the square of a binomial. So if we were to factor this, this would give us x minus 2 twice, or just x and then half of this squared. And then this is going to leave us with equals a negative 26. And then, of course, we're just going to put our y back over here. So y is equal to negative 2 times x minus 2 squared plus 26, leaving us with a vertex of 2 comma 26. Okay, so hopefully you got the exact same thing that I got. So we have one more problem to do in these notes, and we are going to need our graphing calculator for this one. So if you need yours, go get it, and press pause, press play when you're ready, and we will do it. Okay, so you're going to need to type this equation for Dazzling Diver Dan as he dives off a 3-meter springboard. The equation that follows his dive is negative 2.8x squared plus 7.4x plus 3, where x is in seconds and y is in meters, and we're going to sketch the graph. So here we go. Got it typed in over here. Going to graph it and see what it gives us. And we just need to sketch that graph. So, of course, it says that we are starting 3 meters off the ground. So we have 1, 2, 3. We're going to be starting over here. And then we're going to be going up. And then we're going to be coming back down. And we're going to splash. So, we got to find out what some of those other crucial points are by using our calculator. So, obviously, one point you know you're going to have to find is the maximum. So, we're going to second trace, find the vertex, which is our maximum, and we need to back this up until the blinky guy is to the left of the maximum. There he is. So keep on going till you get to the left. And you press your enter. And then you take your blinky to the right. And press enter. And we're going to go jump to the top. And guess where our maximum is? And we're going to find out that it is at 1.321, comma 7.889. Okay, so that appears to be our maximum. So now another thing that we're going to want is we're going to want to find out where it crosses the x-axis over here. We know this is at 0, 3. So we press our second table to see if it's pretty, and yes it is. Look at, we have 3, 0. Okay, so from there we've got enough information. Now we're just going to use our graphing calculator to take care of the rest. Okay, so this is what's going to happen. It says, at what time would Dazzling Dan be 5 meters above the surface of the water? Well, we know that he has a maximum height of 7 something, so we're just going to go up here and we are going to graph the line y equals 5 in our graphing calculator. So in y2, make sure you type in 5, and we are going to let the graphing calculator find it. So you press graph, and you've got that horizontal line at 5. That represents 5 meters above the water. So what you're going to do is you're going to go find second calc, or the trace button, number 5. We're going to go find the intersections. We have to find both intersections because, as you see, he's going to hit that 5 meter above the water mark twice. And so for the first one, we get close, and we're going to press enter 3 times. And we are going to find that the intersection right over here is at the coordinate 2.337, 5. And if you were to use your calculator to go find the other one, you are going to go find that this guy right here is 0.306, 5. And those are the 2 times at which he is 5 meters above the water. So what time? 0.306 seconds. And 2.337 seconds. Okay, so B is a very similar question. It says, at what time would Dazzling Dan be 2.5 meters above the surface of the water? So you would go back to your calculator and you would change the y2 from 5 to 2.5, and everything else is the same after that, except for, you will notice, now is only going to cross it once, because remember, he's already starting 3 meters above. So you would just go to your 2.5, you'd graph this line, we'd go find that intersection point, which I will tell you right now, your calculator is going to find that to be 2.709, 2.5, and that would tell us that it would be 2.709 seconds. Okay? So let's see what else. At what time would Dazzling Dan enter the water? Well, one of my hobbies or habits is finding our important points right off the bat, and we already found that this intercept is 3, 0. That's 0 height above the water, which means that's going to take him a grand total of 3 seconds before he hits the water. That's what our x-intercept represents. Okay, so what is his height at 2 seconds into the dive? So 2 seconds into the dive, we just press second table and go find out what this equals at 2. And after 2 seconds, he is already down to 6.6 meters. And that's just a simple look at the calculator, 2, 6.6. Okay. And then the last question is, what does the y-intercept represent in the problem? And that's the height of his springboard. All right. Talk about using every last second of the video. This is Longo. I'm out. See you. Bye.